wanted it to be all controllable through this MIDI controller. So, like kind of no screens required, you know, your computer doing other things, and trying to have it all kind of intuitively controlled through the MIDI controller. It's intended kind of on the small to mid-sized scale of light shows. Like, I'm not trying to have like a big festival rig or anything hook up to this, but kind of house party, that kind of thing, that's what I'm kind of aiming for. And yeah, wanting it to be performance-centric, so as few hard-coded values as possible. A lot of other lighting software, it's about spending, you're kind of in two modes. You're in like this mode where you're doing a lot of setup, building up your preset library, and then you go into like live mode where you're playing back through all of your presets. But I kind of wanted to build some software that would let me kind of explore different combinations on the fly, build up different looks, and kind of have these building blocks that let you kind of compose them together in interesting ways. And then kind of maybe on the technical side, I've kind of taken an approach on this project of kind of writing code, having kind of this pipeline of features that I'm working on, and trying to not architect things too prematurely, kind of waiting until I've got 3 or 4 examples of something before I can properly split something out, and trying to like happily have a 200-line function if I don't really understand where the abstractions might sit within that. So a little bit about DMX. DMX is the protocol that's used to control any kind of stage lights, like these 2 lights that I've got here. It outputs at 40 Hz, 40 times a second. You have 512 bytes in each packet or frame of that output. 1 byte is kind of 1 channel in DMX parlance. And a fixture or a light, which is between 4 and 30 channels. So these, the ones on the sides here, they're just 4 channels. That's just red, green, blue, white. And the one in the middle here, that's using 29 channels because you can control 8 different kind of pixels along the bar with red, green, blue of each kind of pixel there. So yeah, in one universe you're limited to 512 channels. But if you're doing a very large show, then you might be using dozens of different universes to control all of your lights on your stage. So the hardware I've got, this is a Akai APC Mini controller that I've been kind of writing all of my MIDI mappings for. I've got an adapter here, USB to DMX. It's kind of like a serial, exposes itself as kind of a serial port. Pair of lights on the side in 4-channel mode and a light in the middle in 29-channel mode. So, time for the demo. Is anyone here photosensitive at all? No? Good. Yeah.
Yeah, no. The photosensitive is different.
Would flashing lights be an issue?
No. Photosensitive is too bright. Like, too bright gives you
sure.
discomfort. Yeah.
Well, yeah, I'm not pointing lights in anyone's eyes.
No.
So, so to start with, I've got a palette of 8 colours here: white, yellow, orange, red, purple, blue, teal, green. Then you can kind of, the lights are stuck in 2 groups. The lights on the sides are in one group. The light in the middle is in its own group. So you can change the colour of the different groups of lights. Then you can also kind of control the brightness of the different groups. So you can kind of fade them up and down individually. Then you've got like a global kind of master brightness as well. Then I've got dimmer effects. So I'll slow that down. So this is just a pretty sure this one's a sine wave. The brightness is kind of going up and down. This one. There we go. I think this one's a sine wave and this one's a triangle wave. So sine wave is going nice and smooth, triangle wave is kind of going up and down like that. This one's like a sawtooth up, so it just kind of goes up and then cuts back down to 0. This one will be sine up, so it spends a long time kind of at the bottom and a long time at the top, and then it moves quite quickly in the mid-range. This one's a sawtooth down, sine down, and then this one's kind of straighty, so it goes, it's at full brightness to about 20%, and then it's got a bit of a tail on the end of it. Then you can kind of build up patterns of this stuff. So, go a little faster. So here, it's on the 1 and the 3 beat, it's doing that like kind of strobe kind of pattern, and then on the second off beat, it's doing the like a sine wave. And this is another kind of variation on that. This one goes up 3 times, and then it goes up 3 times and then down. So it looks like once it kind of goes a cycle over like that, and then the other times it kind of goes up. So with these dimmer effects, I've also got this control of this kind of compressor control, where if I go up one way, it pushes values towards full brightness. So you can see here that like the light kind of comes on quite quickly and it's quite bright. And then on the opposite ends, it kind of pulls values away from 1 and keeps them closer to 0. So it kind of, it looks more dynamic with this setting. Next, I'll look at some of the color effects. So I'll just set the 40% color. So here it's going from moving 140 degrees, I think, on the hue wheel in one direction. So this is only called teal to purple. And if we go to red, goes from red to green. Like following a curve as well, I think this is a kind of half of a sine wave. And yeah, you can control the speed on all this stuff. Then this one here is doing a similar thing, but the lights are kind of offset from one another, so you can see that they're kind of alternating back and forth. To make the effect a bit clearer. This one's just kind of a step sequence between a few different colours. So you have like base colour at a 0 degree hue offset, and then you step up to like plus 30, plus 60, back to 0, and it's like kind of steps through that cycle. So you can build up like these kind of looks. And then with the secondary lights, you can kind of set them to a different colour. And then they're all kind of stepping through, and like the relationship between the hue kind of stays the same. This one, it will randomly flash each of the lights white over an 8-step sequence. So we're kind of doing that. Don't know what I'm doing here. Cool. And then one thing I was working on last weekend is, as I mentioned earlier, this bar down on the floor here, you have 8 individually addressable kind of pixels on it. It's got 24 lights on it in groups of 3. And you can address each pixel. So here is an effect for the lights with clearer. So it goes out a couple of times and then in. This one bounces back and forth. Side. Going into the middle again. And that one's bouncing back and forth as well. Yeah, so that's kind of demo done. so kind of digging into a bit of how I've implemented this thing. Mostly got this kind of unidirectional data flow. So on the one end, you've got MIDI events that are coming from this, which feed into what I call my lighting engine, which has a state. That lighting engine then, kind of 40 times a second, it's rendering out what the lights should be doing. It renders those states out into kind of these models of each of the fixtures, and then it outputs that over the USB interface to the lights. Then separately from the output of the actual lights, it also updates kind of the pads here, so you can see, like, as I'm picking the different effects, kind of lights on the pads. So I'll kind of trace through that from beginning to end. First, we've got our MIDI inputs. We've got the concept of buttons and button groups. So here, changing the color. Each color is a button, and all of these color buttons are in a group. Then you've got meta buttons. So what I was showing before about having the speed control. That speed control is kind of a meta button, which I've kind of from everything else. You've got faders, so I was showing before. And to implement this stuff using the core MIDI crate, which is just a thin wrapper over Apple's core MIDI framework. And there's a library called RMID, which kind of had some of this MIDI stuff, and I think I just needed a very specific subset of that, so I just copied and pasted the 100 lines that I needed and used that. So, MIDI mappings. Here's an example of button group. Create a button group, and it's got a type of switch. There's 3 button types as a switch, which means that one of the buttons in the group must always be on. Then you've got a toggle group, which means that either one of the buttons are on or none of the buttons are on. And then there's a flash button, which is only active while the button's held down. So you have a group, and then you list off each of the buttons. Each button you say which MIDI note it correlates to. And then with that button, you specify what the action should be when that button is activated. So here we're saying the action should be to update the global color to white. This is a bit more of a complicated one, and I'll get into some of the specifics a little bit more when we're talking about effects. So here we're saying for note 52, the action should be to activate a pixel effect, which is one of these ones. And kind of specifying what the parameters of that effect should be. And then these are the meta buttons. So I've got tap tempo as a meta button. There are these scenes, so you can kind of set up different looks in each scene. And then you kind of go between them, and it will remember what's been set up for that scene. And yeah, fader mappings. So in MIDI, there's kind of 2 concepts that we care about here. There's MIDI notes, which is what kind of all the pads and all the buttons do, which is just on and off. For the music stuff, you have the velocity as well, but we don't really care about the velocity here. So for a fader, we say, so yeah, there's notes, and then there's control channels, which are values between 0 and 127. So here we're saying for fader 56, it's a fader for the master dimmer, and we can specify what the curve that we want on that fader to be. So here we're saying we want it to be root 1.25, which kind of nudges the values up a bit, which just makes it a little bit more playable. This is all wrapped up into a MIDI mapping where we have our faders, our button groups, and our meta buttons. So all those buttons, they produce MIDI events when they're pressed. We need to convert those MIDI events into lighting events that the lighting app understands. this is the MIDI event I was kind of discussing earlier. You've got note on, note off, control change when a fader is moved up and down, and then you've got about 50 other MIDI events that I don't care about, so just chucking them in the fourth item of the enum there. Then I've got my lighting events, which are these are kind of the app-specific events that I care about. Things like updating the master dimmer, updating the dimmer of the group, changing color and dimmer effect intensities, changing the clock rate, which is kind of it's like the multiplier of how fast the effects run through, changing scene, and then all of the buttons, they're just kind of passed through as buttons. I won't get into that bit too much, it's a bit complicated. And the tap tempo, and when that tap happened. So the code's a bit messy on the screen here, but this is kind of the glue code that hooks up to the core MIDI library. So we have our MIDI client, which is hooked up to the Akai MIDI controller. And we're saying on the input port from that, so we're receiving messages from the MIDI controller. It has this like kind of callback syntax where each time MIDI data is available, it's presented in this packet list. And what we do is we loop over each of the packets in that packet list. Then within each packet, I found this out from having weird bugs that I couldn't understand. Within each packet, you can have multiple messages. And all of the messages I'm dealing with are 3 bytes. So I split them into chunks of 3, convert them into MIDI events. Then I send them just onto an async channel, that MIDI event. Next, I think I've skipped a step here, but once there's kind of those MIDI events, we then have to convert those MIDI events into lighting events, which are the things that our app actually cares about. So we have kind of quantum MIDI mapping, we have this function, MIDI for lighting event, and it matches on the MIDI event, sees what the type is, control change, note on, note off. And when we get the event in, we look up which control or button is hooked up to, and then for each button itself, we we find the right button to convert it to a lighting event, and then for that button we get it to convert it to the correct one. And it returns an option lighting event because there are events that we might not care about. So yeah, this is the way that it's kind of glued together. You get your MIDI events, then you convert your MIDI events into lighting events, and then we only spit out the ones that actually convert successfully. The way that looks like, kind of there's like this main event loop that's kind of running, is we have a state, then we have this tick stream function that my friend Charlie helped with, which once every 40 times a second, it just emits a tick, which kind of keeps the event loop going. And then we have our lighting events. It then uses this async stream select, so whichever event kind of comes first, it'll grab that event, and then one at a time in a kind of a serial fashion, matches on the event type. If it's a tick type, that's when it goes through and updates what the lights are doing. If it's a lighting event from the MIDI controller, then it will update the state based on that event. Cool, so that kind of is how we get user input into the app. Next, we've got a lighting engine. It's got a few key kind of things inside of it. It's got a clock, it's got the scene control, active colors, any dimmer effects, any dimmers that might be set, and any effects that might be set. So this is what the structure looks like at the moment. It's kind of like just the state of the world. It's like a root React component or something that just has all the stuff in there. So yeah, clock, dimmers, speed multiplier, scenes, etc. So the clock, the clock instance has a time that it started at. It's got a BPM, and it keeps track of any taps that have happened for tap tempo. So if I do something like this, see it, if I tap really slowly, you can see it going quite slowly. So once you've done more than 4 taps, then it'll, like each tap you do, it updates the taps here. Then once you've done 4 taps, it sets the starter up to the time of that last tap. And then it just gets the duration of how long the taps took and how many taps there were, does a tiny bit of maths, and figures out what the BPM should be. Then next we have a clock snapshot. So for each tick, one of the first things it does is it grabs the clock, and we get a snapshot of that clock. And all the effects, they all run off of this snapshot. So it's like this kind of consistent state that everything runs off of for one tick. The snapshot kind of has one key method on it for the effects called meter elapsed percent. Meter is, as far as I can tell, the generic term for kind of a duration of music, whether that be 1 beat, 1 bar, 1 phrase. It's kind of the generic term for that. So here we're seeing how many seconds have elapsed since the clock has started, how many seconds long this meter is based on the BPM. So if we're running 120 beats per minute and it's 4 beats to the meter, that's 2 seconds for the meter. We then use a modulo to find out which kind of cycle we are through. So we want to know for the most recent cycle, what percentage are we through that, and we return that as a number between 0 and 1. So that leads us into effects. I'll just talk about dimmer effects because they're kind of the simplest one. The same concept applies to the other types of effects. First, we've got a waveform. A waveform is a mapping function that takes an input between 0 and 1. That's how far we are through the current kind of animation cycle. And then it applies some sort of simple mathematical function to that to turn that 0 to 1 into a sine wave or a saw wave or some of these other like exponential kind of effects that I've been working on. So you just have that waveform, which kind of, if you're going to do music, it's like a LFO. That's kind of the shape of the LFO. Your waveform then goes into a dimmer modulator, which is like an individual step in that effect. So the simple effects will only have 1 step. So there'll be 1 modulator and you'll have an effect with 1 modulator within it. And that kind of wraps up some of this config. So you've got your waveform, how long that should run for, and also a min-max scale. So if the output should be between 0 and 0.5, or if it should be between 0.5 and 1, or the full range 0 to 1. Then finally you've got your dimmer effects, and the main thing this does is it kind of wraps this stuff up. So if you've got an effect that has, I don't know, let's say 4 modulators within it of varying lengths, it's got a function that figures out what the current modulator and what percentage through the current modulator we are. So here's the waveform, saw up, saw down, triangles, sines. And it works with this, it's got one method on it, apply, which takes the input of how far through we are, and then applies our functions. So you can see here, like saw up, this is returning x back out, saw down 1 minus x. Same deal, sines a little bit more complicated. I think the next slide. Yeah, so there's an inbuilt markup which is really useful for this stuff called grapher, where you can just kind of, particularly for these kind of simple equations, you can just go y equals and just type in whatever equation you want, kind of prototype with this stuff, and then once you've figured out your equation, then you can kind of convert it into Rust code. It doesn't really copy and paste very nicely, so maybe there's a chance for like a web tool there that lets you copy and paste that into Rust source. So yeah, then you've got your dimmer modulator, which has things I was just talking about, the waveform, how long it runs for, the scale on which it's running on. So then you apply the waveform to how far through the current animation cycle we are, and then you scale that. then the specifics of that code doesn't matter too much. But here we're taking in the clock, and then we're just figuring out which step we're up to and how far through that step we are. So once all that's done for an individual effect, I'm glossing over some details that doesn't quite line up with what I was just saying, but once we've figured out how one effect kind of works, it's really, really nice how numbers between 0 and 1 compose together. So here, to get the kind of the current effect value, we start with the number 1, and then all of our dimmer effects are numbers between 0 and 1, so we can just multiply it together. So if our first effect wants us to be at 0.5, and our second effect also wants us to be at 0.5, we just multiply together really nicely to 0.25. And yeah, this has proven really nice as a way of like composing these effects together. And then likewise, to get the dimmer value for a given fixture, we take the master dimmer, we take the group dimmer, this is the group dimmer here, of that group. So multiply the master dimmer, the group dimmer, and the effect dimmer all together, and that's how you get the value for the current line. So those are all the effects. Now we're moving down the pipeline a bit further. We've got our fixtures. Our fixtures have a profile which maps out what the channels do on each of the fixtures. They have a universe number and a start channel. So I'm using Toml to configure my fixture profiles. Here, just saying what slug, label, channel count is. Then for each channel, I'm saying channel 1 is the parameter red, 2 is green, 3 is blue, 4 is white. It's a bit tedious when you've got 29 channels, but get over it. These are the parameters I've got so far. You've got the dimmer value, red, green, blue, white. I've got some moving headlights as well that I haven't written effects for yet. So you can control the pan and tilt of those. Then for each channel, a given channel will have a parameter, to say it's the red channel. That will then have the channel number that is for that light. So it could be 1 or 2. We'll gloss over the beam bit. Then you can have a min or a max value. So it outputs between 0 and 255. But what you find with some of these lights is they'll use one channel for 2 or more mutually exclusive operations. So they might have 0 to 127 being the dimmer, and then past 127 that might be strobes of varying speeds. So you need to be able to set a bounds on that. Next we've got a fixture beam. So the lights on the sides, they're just one beam each. The one in the middle that has 8 beams, or pixels as I referred to them earlier. And for each of these beams, we say what the dimmer, red, green, blue, and white is. Then here, this is kind of the project setup. So this is where we've configured what our individual fixtures are going to be doing. And now for our overall project, we're saying that our first light on channel number 1, that's a 4-channel par can on the sides, and by group 1. Then we're saying the second light starts on channel 5 because they're 4 channels, also group 1, next one starts on channel 9, etc. So you've got the fixture profile, then you've got the fixture, which is like one actual light. That's got its profile, universe, start channels, kind of what I was just showing. Optional group, it's got beams, and it's got a position, maybe. Then, again, the specifics of this code doesn't matter too much, but once you've got a light and you say set the color of it, or set the brightness of it, you've got to take those values that you've set and convert them into the actual bytes that you're going to write out to DMX. So to do that, we start off by creating just a vector of zeros of the number of channels that it's got. We then kind of loop over all of the parameters that a light might have, and you can, with this dimmer example here, you can see that we're looking up the index of the dimmer channel and setting that to the encoded value of that dimmer. So the dimmer here would be between 0 and 1 as a float. We then need to convert that to an 8-bit integer, and if there's any mins or maxes on that fixture profile, we need to take that into account as well. Then that's kind of the relative DMX, so that's the specific light. So the two on the side here, they're both going to be outputting the vector with 4 bytes in it. You then need to write that out into the full 512 byte buffer. And to do that, we have the buffer that's passed mutably, and it kind of finds its spot in how far through it has to be in the 512 byte buffer, and writes those bytes in accordingly. So this is kind of glue code that ties it all together. We take in an iterator of fixtures. We return out a hash map where the key is the universe number and the value is that 512 byte buffer for array here. We just kind of loop over, find the right universe, put in a blank universe if one doesn't exist yet, and write out that DMX data. So this bit I've kind of glossed over a tiny bit. To output DMX, I'm using this app called open source library app thing called Ola, Open Lighting Architecture. That's why it's called Roller, Rust, Ola. And on top of Ola, I wrote a little, using async STD, just like a little TCP client on top of that, because it accepts just TCP as its input. The messages that you send to Ola, they're protobuf messages with that kind of, it's not gRPC, but it's got a custom kind of like little framing thing on top of that. So I've used Prost to generate types of that. Prost is really quite nice. And I've trained the whole fixture cover as well. So yeah, I instantiate an Ola client like that. I won't show the specifics of the code here. It's connecting to the local host at port 9210 or something. Wait for that to be good. Then to send the DMX data, we just send off the data and wait for it to complete. So that's all kind of where it's at so far. In terms of future expansion, I want to add movement effects that I mentioned. Still trying to figure out exactly how to do that. Kind of thinking about having Bezier curves of movement patterns or something. Quantization, so when you hit buttons on the controller, it snaps it to the nearest beat or nearest bar, which makes it all a bit more professional. Being able to modulate effects by clock rate, I think that'll be really fun. So kind of an effect like this, and then you have another waveform that's then speeding up and slowing down the rate of the animation. So it would get really stretched out and then really squashed in. I think that'd be pretty cool. Effects, fades, and transitions. So at the moment, as soon as you hit a button, it just turns the effect fully on. Having it crossfade into an effect would be nice. I showed off the scenes feature earlier. I don't think it's going to be very hard, but just being able to autoplay through it, you can set up 4 or 8 different scenes, and you have a loop, one phrase per step, and then you kind of set. And then external MIDI track to sync input. So on the creative side, on the technical side, I'm pretty sure I could get this running under WASM using web MIDI for the MIDI input. Then I'd probably use some sort of WebSocket type thing to output the output some data from the browser app up to like just a little WebSocket to TCP kind of bridge. A rep would be really fun so that you can play around and experiment. Artichoke looks interesting for that. And then kind of halfway creative and technical, having perceptual color balancing would be really fun. So at the moment, if I go purple, that's blue and red both fully on. If I go red, that's just red fully on. If I go blue, it's blue. But if I could kind of balance those color outputs based on like how the perception of the brightness. I think that'd be pretty fun. So yeah, thanks for listening. If anyone's ever played.
Cool. Before anyone asks a question, I'll ask. Thought about using an envelope to do the animation.
Yeah, I haven't thought too deeply about it, but there's something to it. Yeah.
Yeah.
But kind of how to incorporate that, I'm not quite sure how I fit it in.
Tools and sliders.
That was my meta question, was what do you mean by an envelope? Like with sliders?
Sorry. So with synthesizers, you've got as part of an envelope, your attack case and release.
Yeah.
So that's how you control the weight or really any values as part of the synthesizer. So you can do that. You can control, how the animation works.
You just have like 4 sliders for it or something? Or...
Yeah.
Like at the moment, I don't have a concept of when like an effect itself starts.
Yeah.
The effect is kind of in a way always running, and you're just kind of turning it on or off.
Yeah.
It needs a concept of like when an individual effect might start.
I have what I think might be a dumb question. When you said house parties, it made me think of Lightbox and Philips Hue. Have you looked into integrating with them, or are they just like too slow to talk to or whatever?
The latency is a big issue, and I don't know, this gear's kind of made for it.
Yeah.
I think you could pull it off, but it helps with some things. You're fighting against the system in other ways. Maybe you come out even. I don't know. And Philips Hue don't sell a strobe light or whatever. So.
What was your original motivation for doing it in Rust?
I've been doing Rust for about 2 years now, and I've just completely and utterly fallen in love with it. And if I could, I would probably not start a new project in another language.
Okay.
So